Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to go over how to find the inverse function for a given function f of x. On the screen I've got the 4 steps we need to follow. We'll begin by replacing f of x with the variable y. Then we will switch x and y, and I'll talk about that in just a minute. We'll solve the new equation for y, and then we'll rewrite it using function notation. We'll replace y by f inverse of x. So the real important step here is step 2. What allows us to do that? Well, the idea is that a function takes a value x to its output value y. The inverse function would reverse that pattern. The input is the output of the original function and vice versa. So because we're switching the input and output between the two functions, that's why we switch x and y here. We're going to work through 3 examples. The first one's a linear function, then we'll look at one that's quadratic and one that's cubic. For the first function, we have f of x equals 3x minus 15. Now, if we think about this a little bit, we're taking an input, we're tripling it, and then we're subtracting 15. We're going to see that when we find the inverse, it's going to do the opposite or reverse operations in the reverse order. So instead of times 3 and then subtracting 15, if we go in the opposite direction, we're going to add 15 first, and then we're going to divide by 3 second. Let's see if that actually works. So back to the steps. First thing I want to do is replace f of x by the variable y. Okay, y equals 3x minus 15. Then I'm going to switch x and y. Everywhere I saw y, I write x. Everywhere I saw x, I write y. X equals 3y minus 15. By the way, you could probably do both of those steps at the same time, right? Get rid of f of x, put x there. Everywhere you had x, put y. Now we need to solve this equation for y. So first, we'll add 15 to both sides to isolate the term with y. X plus 15 equals 3y. How do we solve this for y? We're going to divide both sides of the equation by 3. And so now we have x plus 15 all divided by 3 equals y. We finish by writing this in using inverse function notation. F inverse of x is x plus 15 divided by 3. Now, this should have made sense, right? If we look at the inverse function, what's the first thing it does? It adds 15. That was the last operation in the original function, and it was reversed. Right? Instead of subtracting 15 last, we're adding 15 first. Instead of multiplying by 3 first, we're dividing by 3. It's inverse operation. We're dividing by 3 last. So there is the function. If you want to test it, pick a number, plug it into f, plug the output into the inverse just to make sure. It's a way that you can check your work. So for example, if I did f of 10 would be 3 times 10 minus 15. 30 minus 15 is 15. If I plug in 15 to the inverse function, I better come back and get 10. In the numerator, 15 plus 15 is 30. 30 divided by 3 is 10. So you can verify that these are inverses. It's a good way to check your work. Let's try one that is quadratic. I've got f of x equals x squared minus 4, and it's restricted to x being greater than or equal to 0. And that's because if we don't make that restriction, the function is not one-to-one. The graph of x squared minus 4, remember, is a parabola, and that fails the horizontal line test. But if we restrict it to x being greater than or equal to 0, it looks something like that, and that is one-to-one. We can find an inverse function. We'll use the same steps. Y equals x squared minus 4. Switch x and y. X equals y squared minus 4. Solve for y. Add 4 to both sides. X plus 4 equals y squared. And then we can take the square root of both sides. The square root of x plus 4 equals y. That is our inverse function. By the way, the domain of the original function was x is greater than or equal to 0. The range would be y is greater than or equal to negative 4. That needs to be the domain of the inverse function. So here, we're going to say that x is greater than or equal to negative 4. All right, one more to go. This is one that's cubic. So I'm going to show you what I was talking about, doing both of those first steps at the same time. So instead of starting with y equals x plus 4 cubed minus 7, I'm going to jump right to x equals y plus 4 cubed minus 7. Add the 7 to both sides to get x plus 7 equals y plus 4 cubed. And if you're not sure about how to solve this, think about this equation here. If we were going to plug in a number for y, we would have added 4, then we would have used the third power, and then we would have subtracted 7. We want to peel those off in the opposite order. So we got rid of minus 7 by adding 7. To get rid of the third power, we need to take the third root of both sides. The third root of x plus 7 equals the third root of y plus 4 cubed, but that just equals y plus 4. Now we can get rid of the plus 4 by subtracting 4 from both sides, and we get the cubed root of x plus 7, all minus 4 equals y. That is our inverse function. F inverse of x equals the cube root of x plus 7 minus 4. If you wanted to check this one, pick a number to plug into f of x first. If you're trying to work with f inverse, it's going to be tough to come up with one where it's a perfect cube inside the radical, and it's easier to check going the other direction. So let's say we plug in 1 for x. 1 plus 4 to the third power minus 7. 5 cubed minus 7 is 125 minus 7, or 118. If we plug in 118 down here, I've got the cube root of 118 plus 7 minus 4, or the cube root of 125 minus 4, or 5 minus 4, which is right back to 1. So everything seems to work out here. All right, in the next video, I'm going to separate this one out. We're going to find the inverse of a rational function.